In this video, I'm going to go through the solution to question 27 from the 2025 Australian Math Competition Senior Paper. A 28 by 28 centimeters square is cut out from the center of a 36 by 36 centimeter square piece of paper, as shown on the left. The smaller square is rotated so that its corners are on the edges of the original square, as shown on the right. In square centimeters, what is the combined area of the four white triangles not covered by the rotated square? Okay, I'm going to let this length here be A, and this one be B, and this one be C. So similarly, I can argue that these are also A, B, and C, just by symmetry. Okay, now, what else can we say? If I extend this line, this is a square. By symmetry of rotation, I can argue that these triangles on the outside are exactly the same as the triangles on the inside, just because they are rotated. Their areas are still the same and they have the same right angle. They should be the same, right? So this is also going to be C and B, and of course, there's going to be A as well. So this is B on the outside and C on the inside. So all of these are the same. What do we know about A, B, and C now? Firstly, we've got Pythagoras' theorem from a right-angled triangle. A squared plus B squared equals to C squared. Okay. And also the side length. As you can see, in any of these sides, we have A, B, and C all appearing once. And we know what that length is. We're given in the question that it's 28. Okay. Maybe that's not enough information for us to work out what A, B, and C are, but we also have this. Look at this blue triangle over here, and look at this red triangle over here. They are similar because all their lines are parallel, so they have equal angles. So we can see that the blue and red triangles are similar. And what is the ratio of their sides? Well, the blue triangle, the hypotenuse is A plus B plus C. And the red triangle, the hypotenuse here is just C. So this is the hypotenuse of the triangle. And then what is the sum of the legs of the triangle? Think about this. By symmetry, this side is equal to this side, right? I can just move it up there. So the sum of these two sides is just the very outside of that shape, which is the 36. What's the sum of the legs of this? That's just A plus B. So this is the sum of the legs. And because these two triangles are similar, I can conclude that these two ratios are equal to each other. So the hypotenuse, the ratio of the hypotenuse is equal to the ratio of the sum of these legs. Okay. We are given that A plus B plus C is equal to 28. So let's substitute that in. 28 on C is equal to 36 on A plus B. I can cross multiply. I get 28 A plus B is equal to 36C. Dividing both sides by 4, that gives 7. A plus B equals 36C. Divided by 4, that's 9C. So, A plus B, I divide by 7 again, we get 9 on 7C. Okay. A plus B is equal to 9 on 7C. Once again, I'm going to substitute that into this equation. A plus B plus C is 28. We know that A plus B is that. So I can say that A plus B plus C. I add another C onto 9 on 7C. That's 16 on 7C is equal to 28. So what is C equal to? So 16C is 7 times 28. C would be 28 times 7 over 16. I'm going to divide top and bottom by 4. So that's 7 times 4 times 7. 4 times 4, so that 4 cancels out. 7 times 7 equals 4. C is equal to 49 over 4. Okay. Now, what do we have here? C is equal to 49 over 4. I can square that. So C squared is equal to 49 squared over 16. I don't work out 49 squared because it's too big. I might make a mistake, but this is C squared. We now know this is 49 squared over 16. Okay, let's continue. A plus B. We have A plus B will be equal to 9 on 7C. We have this, and we just worked out what C is. So 9 on 7 times 49 over 4. The 7 and the 49 cancels out, and we get 9 times 7 is 63 over 4. And now I can square both sides so that A plus B all squared, which is A squared plus 2AB plus B squared, is 63 squared over 16. Again, I don't work out 63 squared because it's a very big number and I don't want to make a mistake. What is the combined area of the 4 white triangles not covered by the rotated square? That's what the question is asking us, right? So what is that area that we want equal to? So the area of the 4 white triangles. What is that area? 4, because each of the squares have the same area. And that area is half times base times height. This white triangle over here. Base and height are A and B. AB on 2. And that is exactly 2AB. 2AB is exactly equal to this minus A squared plus B squared, which is that. So, is equal to A squared plus 2AB plus B squared minus A squared plus B squared. Well, what is that going to be? This thing, the first thing is 63 squared over 16. Minus that thing is 49 squared over 16. I specifically don't calculate what 63 squared and 49 squared are because what do I have? I have a difference of squares. So I can actually write this as what? 63 plus 49 times 63 minus 49 over 16. Okay. 63 plus 49 is 112. 63 minus 49 is 14. 16, I can write this as 8 times 2 just for convenience. 112 divided by 8 is 14. 14 divided by 2 is 7. And 14 times 7 is 98. And that is our final answer. And we've done that without having to even calculate what A and B is. So there's the final answer of 98, and we are done.